Think about it. Have you ever bitten into a lemon wedge? Maybe because somebody dared you. How did it make you feel? What happened? Did you purse your lips and get that weird tingly kind of sharp feeling under your jaw, kind of like where your jaw meets your neck? Or maybe it was a Sour Patch Kid or an atomic warhead, who knows? But have you ever had anything that sour? Now, why do you think that same sensation doesn't happen when you bite into a piece of spinach? Well, this brings us to what we're going to talk about today, and that's acids and bases. Right? Acids and bases, categories of compounds that have very specific characteristics all to themselves. By the end of this, you'll be able to identify and define the term acids and bases in terms of whether or not they either donate protons or if they accept protons. We're also going to talk a little bit about neutralization reactions. So what do you think all these things have in common? They're likely a little sour tasting. They could be corrosive, meaning they could wear away or eat away at other materials. Some of them might react with metals and produce a hydrogen gas. And if you were to put them into liquids, like water, they're likely to conduct electricity. Why? Because these guys are all acids. Now, years ago, a Swedish chemist by the name of Irenaeus was studying acids and bases. And he determined that acids can be categorized, or acids can be identified by the fact that they give off hydrogen ions when they break apart in water. So when you put acids in water, they break apart and they give off or release hydrogen ions. That's what that H plus is. H plus is the same thing as saying hydrogen ion. It's the same thing as saying proton, even. Okay, so Irenaeus said that acids, you could know an acid because when you put it into water, it would break apart and would give off hydrogen ions. Fair enough. Now, there's another definition of an acid that you need to know. And this definition says that acids can also be considered proton donors, right? Acids donate protons, meaning they release protons and give them to other elements or compounds in a chemical reaction. So you have to be an acid to donate a proton. Now remember, H plus and hydrogen ion and proton are all the same thing. Now, when I was your age, we called this the Bronsted-Lowry acid-base theory. You can remember that name just so, you have a new piece of information. But definitely you need to know this is an alternative definition of what an acid is. So you need to know Irenaeus' definition and this alternative definition. Now, luckily, in your reference tables, there is a table K, which lists a variety of common acids that you would see involved in chemical reactions, at least for our purposes, right? Now, notice something about all of these acids. Look at their formulas. HCl, HNO2, HNO3. Seeing a pattern? Since acids donate protons or donate hydrogen ions. Generally speaking, the formula for an acid starts with an H. H2SO4, that one starts with 2 hydrogen ions. And does that. Here we have 3 hydrogen ions, or hydrogen atoms. And here we have 2. But now notice, there are a couple of the acids on this slide that don't necessarily fit that kind of definition of what the formula for an acid is, that it starts with an H. So here's the beauty. When in doubt, if you're not sure if it's an acid or a base, look to your reference table. Look for it in table K. If it's in table K, guess what? It's an acid. So, what do you think all of these things have in common? Chances are they might taste a little bitter, probably slippery to the touch. And they also conduct electricity in solution. We were talking about acids. Now we're talking about bases. Oh, there's Irenaeus. He's back. So our little Swedish chemist said that bases broke apart in water as well, but when bases break apart, they give off OH minus ions. Those OH minus ions are called hydroxide ions. So the presence of the OH is usually a sign that the compound is a base. So Irenaeus said that when bases are in solution, they break apart and they release OH minus ions or hydroxide ions. Now, of course, there is an alternate definition for a base, just like there was for an acid. And this definition says that bases accept protons, meaning they take them in. So the way acids give them up, bases take them in. Okay? This was also part of that Bronsted-Lowry acid-base theory. But again, you just need to know the definition, not so much the name. Okay? Bases also have their own table in your reference table, table L. And notice that the formulas end in OH, in those hydroxide ions. That's usually a big tip-off that it's a base. But please be careful. When in doubt, if you're not sure, refer to your reference tables. Now, ammonia, aqueous ammonia, NH3, that's kind of an exception to that OH rule, but it's one of those things you have to remember. And again, if you can't remember it, that's okay, because it's on your reference table. Or you can remember our little sheepy friend and remember the word bad. Bases accept, acids donate. So we're going to do a little practice. You can use tables K and L, or you can use the little hints about the H's and the OH's. We're going to do a little practice to figure out if the formula represents an acid or a base. HF. H is in the front. That's going to be an acid. LiOH, lithium hydroxide. It's got that OH, it's a base. CaOH2, calcium hydroxide. That's a base. H2SO4. There are 2 H's in the beginning, so that's an acid. HCl, again, the H is up front, that's an acid. CH3, COOH. Now you want to say to yourself, oh, it ends in OH. That has to be a base. But that's a kind of funny looking one, isn't it? When in doubt, hit those tables K and L, because guess what? That's an acid. It's an organic acid. So the H in the beginning for an acid, OH at the end for a base, that rule usually works. But just be careful, okay? So let's apply that kind of same idea, but we're going to use the definition of acid and base, where acid is a proton donor, meaning it donates those H+, and bases are a proton acceptor, meaning they take in that hydrogen ion, that H+. So the easiest way to do this is to look at the number of hydrogens in the compound. The first one, H3PO4, has 3 hydrogens. But something happens to it, and it becomes H2PO4. So since it lost an H, it went from 3 H's to 2, we would consider this an acid, because losing a hydrogen ion is the same as donating that hydrogen ion to some other compound. Someone or something else is going to pick it up. So because we went from 3 hydrogens to 2, the number of hydrogens decreased. We say we've donated a proton, we've donated a hydrogen ion, and that's an acid, because by definition, acids donate protons, right? That's that alternative definition. Let's try another one. Is this an acid or a base? Well, let's see what happens. When we start out, there are 3 hydrogens, but look what happens. Now we have 4. So somewhere we picked up another hydrogen ion, or another hydrogen atom. Hydrogen ion, really. So having taken in that hydrogen, I would call this a base, because NH3 gained or accepted a hydrogen ion to become NH4 plus. Right? You see that little plus there? Right here? That means it's an ion, right? It picked up an ion. So we're going to practice with this in just a little bit so you can get the swing of what is or isn't an acid or a base based on donating and accepting protons. We'll get to that in just a sec. But first, an acid can be defined as a proton donor, a proton acceptor, a hydroxide ion donor, or a hydroxide ion acceptor. Well, if you said proton donor, you are absolutely correct. True or false? Hydrogen ions, H+, are the same as protons. I sure hope you said true, because that's the answer. So what I'd like to do with you now is I would like to do some practice with determining whether or not a compound is either donating or accepting a hydrogen ion, meaning, is it an acid or a base? Now remember, acids donate the hydrogens, bases accept those hydrogen ions. So what we're going to do is we're going to look at the hydrogens and count them. If the number goes down, that means the hydrogen ions were donated and it's an acid. If the number of hydrogens go up, that means a hydrogen ion was accepted, and that must be a base. Okay? Because remember, hydrogen ions are the same as protons. So let's take a look at the first one. Here we start with 2 hydrogen and end up with just 1. So since the number went down, we say that it was donated. And which one, acids or bases, donate protons? Well, acids do. Acids are proton donors. Acids are hydrogen ion donors. Acids are H+ donors. Okay, let's look at the next one. We have 3 hydrogen to start with, and we end up with 4. Since we've gained a hydrogen, we must have accepted it. And if you accept the hydrogen ion, you have to be a base. Let's look at the next one. Again, we're counting the number of hydrogens. 3 hydrogen here, 2 hydrogen here. The number decreased, so we've donated a hydrogen ion. And who donates? Acids do. Let's look at the next one. We have 2 hydrogen here, but only 1 over there. When the number of hydrogens decrease, that means a hydrogen was donated. And if it was donated, it has to be an acid. All right, we're going to do this one more together, and then you can do the rest on your own. Just so you know, the answers for all the answers for this data table are the last slide in the PowerPoint. So you have the answers there if you're working on this at home. All right, let's take a look at this one. We have 1 hydrogen here and 0 hydrogens there. So we went from 1 to 0. The number went down. So it must have been donated. And if it was donated, that has to be an acid. So I'm going to let you do the next 5 yourself. And you can check your answers by looking at the answer key at the very end of the PowerPoint. All right? So, acids are proton donors. Bases are proton acceptors. Now, the last thing we have to talk about is something called neutralization. Acids and bases are kind of like opposite sides of the same coin. And they have a head and a tail. When acids and bases combine, they can cancel each other out, meaning they can neutralize each other. And when that happens, we no longer have an acid and a base. Instead, you create salt and water. But in order for neutralization to happen, the concentration of the acid has to be the same as the concentration of the base. So you need to have the same number of hydrogen ions as you do hydroxide ions. So this number, that's for your acid, and this number, that's for your base, have to be the same. Okay? You can say that an acid will neutralize a base, or conversely, you can say that a base would neutralize an acid. But again, they're opposite sides of the same coin. One side neutralizes the other in one order. Whatever order you want to put the words, well, that's on up to you. And when the reaction is finished, what may have been 2 very dangerous compounds, when they're completely neutralized, you get salt and water. Something far less dangerous. It's really pretty cool. So here's an example of a neutralization reaction, and I color-coded it so you can see how the compounds kind of break apart and reattach. Now notice, this looks an awful lot like a double replacement reaction, because it is. All right. HCl is your acid, How do you know? Well, it starts with the H. NaOH is your base. How do I know? It's got the OH at the back end, right? The hydroxide ion. Now look at how they're going to split. So the blue elements are going to come together and create water, and the red elements are going to come together and create the salt. So in a neutralization reaction, acid plus a base gives you or produces salt and water. It's really kind of neat. And if you think about the way like antacids work, you know how sometimes when people kind of get heartburn and they chew on something like Tums, right? They're getting heartburn because there's excess acid in their stomach. The Tums is a base. So when you combine the acid and the base, it neutralizes that strong acid to make the heartburn not so painful anymore. Kind of nifty. So I did this because I want to show you how these guys kind of split apart. All right. So same equation, but I just want to show you what happens. So the acid splits between the hydrogen and the rest of the compound. The base splits between the hydroxide ion and the rest of the compound. Then this hydrogen and this OH combine to create HOH. HOH is just a silly way of saying H2O, which is water. Now these two little red guys here are going to combine and they create the NaCl. So when an acid and a base combine in a neutralization reaction, you end up with salt and water. And that always happens in a neutralization reaction, never changes. Acid plus base yields or gives you a salt and water. Kind of nifty. Now, this is the same formula, but this slide and the next one kind of just explain again what I was saying about how the compounds break apart and rearrange and come back together. You can read this on your own because I just talked about it. And if you want to go through it again slowly at your own pace, that's totally fine. But again, all it is discussing, or I should say all it is the information I just discussed about how the acid breaks apart, how the base breaks apart, and then how the pieces recombine to create salt and water. So what I'd like to do is I'd like to look at a couple of different neutralization reactions and see if you can figure out what the missing product is. Okay? So in the first one, we have HBr and KOH. The HBr is going to split right there between the hydrogen and the rest of it. The base is going to split between the hydroxide ion and the rest of it. And water is already there for you. That comes from this H and this OH. That's where you get your water. So the salt really just comes from what's left. We have Br and K, but you always write it metal first. So what's left is KBr. Not so bad. Let's take a look at the next one. So we have HNO3, that's the acid, and again, KOH is the base. The acid is going to break apart between the hydrogen and the rest of the compound. The base is going to break apart between the hydroxide ion and the rest of the compound. This hydrogen and this OH combine to make the water. So what's left? Put it together and you're done. We have NO3 and then K. But you always want to write the metal first. So it's KNO3. And that's it. I know you can handle that. All right. So we are at the end. Please go to the assignment on Google Classroom. Complete the exit ticket titled Acids and Bases. 5 questions. And be safe. Stay healthy. And